Hello, everybody, and welcome to a new episode of the BIMvoice. Today we have again with us Øystein Ulvestad from Sveko, from Oslo, Norway, who has a very interesting presentation, a very intriguing topic. Hello, Øystein. Thank you for coming.
Thank you very much. Thanks for letting me speak about what I love to do, and it's not that often you get to speak undisturbed about the things you really like. So
You,
thank
you
you very
are
much.
you are more than welcome, and you are in the right place because this is what I try to do here, and I'm really looking forward to learn from these things because you are working with so many interesting and exciting things, and yeah, I'm really looking forward to learn from this.
Thank you very much. So we tried to find a catchy name, so we called it the death of drawings. Using BIM models to improve build quality. The title is because we try to do things drawingless. We try to skip drawings, if we have a look at the agenda for today, a little bit about motivation, why we try to do things without drawings. Why do we want to build directly from a BIM model and not from 2D drawings? Then a little bit about the advantages this gives us when we're building with when we're ordering third-party products for our structure, whether that be a steel or a concrete structure. Then a little bit about what size do you need to do this. You don't really need a huge project to take advantage of this. And then as a bonus, we'll talk a little bit about site vision and how that can be used in different projects at the end.
Nice, sounds
Yep,
exciting.
good. So if we go present myself, I'm Øystein Ulvestad. I graduated in 2000. I've got a master's degree in construction engineering, and I've been working at least for the last 7 or 8 years with bridges, mainly concrete cast in situ bridges. And I'm quite active on LinkedIn, so if anyone wants to follow me there, then please look me up, because I write quite a lot about the projects that we're doing. And lately, Randselva Bridge, that's a 634-meter bridge built without drawings. So a little bit about motivation, and I say this in Norwegian, but the pictures are quite telling anyway. Today, 2021, we do most of the work at site by manual labor, and nearly everything is done by manual labor. If we have a look, say 40 years in the future, then I'm a happy old man, and at site they'll be doing more and more robots and machines at site. But machines do not you don't feed machines 2D data.
Yeah, before you go ahead, can you please go back?
Yeah, sure.
How you came up with this 40 years gap? Do you really believe that it's going to take so long to have so capable machines on our building sites?
No, the reason I chose 2061 was that I started with finding a happy old man.
And
And I
wanted to
thought
match it.
I thought, how old is this man? He's probably 40 years older than me.
Yeah,
So
but what about this? Like, do you really
yeah.
believe it's going to take 40 years for us to get robots, productive robots on our building sites?
No, definitely not. But like trying to look into the future, when they send the first people to the moon,
Yeah.
they would be very disappointed if they knew where we are at today. We still haven't sent anyone to the moon since 1970 or whatever. and they thought we would have flying cars and whatnot. So I want to be a bit careful in saying to what extent do they have machines, but 40 years is a very long time. So hopefully and probably a lot more than what I'm guessing here.
I believe also because the how the technology has developed lately, it's growing exponentially. Uh, I think we have everything in place to achieve this much earlier, not a mass scale, not globally, but at least in some countries. I strongly believe like we should have this by 2040. On some building sites, on some countries, we should definitely, we have technology, and not only that, we have something that is even more than that, more important than that. We have people, visionary people, that see potential in this and are trying to direct funds and to invest in this. So I think we have the ingredients for a success story. But like I said, not to complete scale, to full scale, but locally.
I think that the key is standardization, both of data and building technology, like in making standard units. And if you manage that, then you can roboticize a lot more than if you don't. I'm not very good at predicting the future, so so I don't wanna predict too much. But what I do know is that whatever we feed these robots, it will not be 2D drawings or PDFs. It will be digital data. So if we have a look at this one, this is not the way you will do it. You will not dumb things down to 2D and then feed it to robots. You need to feed them 3D data in some form.
Or not. Let me say this. Maybe not even 3D data. They don't need to see it 3D, right?
No,
they can read it if you as instructions, or right?
But the people who's making the instructions, they need to visualize it somehow. And that's better done 3D and then 2D.
Of course. As long as people will still be involved in this, of course. But when we will have AI architects and engineers that will design a complete bridge instead of us, then you remove. So if you remove the people from here, from the equation, you have a streamlined process, robotized, right?
True. Then of course the question is, how do you quality control it by a human? But that's another discussion, of course. But so the interesting thing here then, and the motivation to do this is, if and even in the end, when it happens, you'll have robots doing manual work. But to get there, we need a transition where humans learn to build from 3D models before that can happen. So back in 2010 or whenever this process started, then every worker was reading 2D drawings. Then you now in 2021, at least in Norway, you have now a period where humans need to learn how to read and extract information from 3D models, digital data. And then you will, because you can't really have 3D models and 2D drawings going parallel for too long. So, and then when humans know how to read 3D data, then you can slowly start making robots understand 3D data.
Yeah, well, regarding having 2D drawings and 3D models would not be efficient. You can have it, but you will just burn money, right? And you will not be competitive. Like you will have your competition doing only skipping drawings, and you will be left behind, of course.
Yeah, and at some point you need to start producing 3D models to standardize them. And so the key standardized data sets, and that's not something you just start doing in one project. You need that to come gradually, just for humans to understand the data and machines to understand the data. That needs to progress slowly and gradually. And then we'll also have a look at third-party products, like we said. When we're doing a bridge like the bridge we're building now, Randselva Bridge, I guess 90-something% of the bridge, that's things that we produce ourselves, concrete and reinforcement, and to a certain degree tendons. But then we have things like we show in green here. We have a joint, and a joint it's very important that it's fitted correctly. And normally you'd only have 2D drawings to do this. And in a complex structure where you have a lot of reinforcement as well, it's quite hard to foresee everything that might clash. So so getting a good 3D model from the deliverer is very important. In this case, it's Maurer, and they've provided us with the IFC file. That's been very, very useful.
Wow.
So having a look at the same joint, just in different ways of displaying it, we can now very clearly see what we need to adjust to make this fit the structure. And the good thing here is that, or rather the difficult thing here is that when we start the project, we have no idea who the deliverer is. So we need to reserve some space, but we do not want to reserve too much space, because then we cannot finish any of the pouring stages next to the joint. Another example is the free cantilever parts. So I'll stop here for a little bit just to show the layout of the bridge. So this is the bridge. The joints we had a look at, they're located at the ends of the bridge. So here in axis 1 and in axis 8. And for example, when they start building this part, then they do the hammerhead first, and then they build the first segments on either side. And to build these segments, they need
formwork.
Yeah,
formwork.
Correct. So you'll have one of these on either side of the structure. And the forces and the weight of this is quite large. So we need to hold them in place, and we do that by making holes in the concrete. And those holes have been, from our side, they're symbolized by these marks. And here we then get a very detailed 3D model of the deliverer of the scaffolding, the product, that we can then, for casting of the second segment, then I can very easily and visually check whether the holes fit the holes that I've made in my structure. Because it would be quite devastating if we had to start drilling new holes here.
Yeah.
And here we see they fit perfectly at all the stages where I need them to fit. And if we go down here on the lower end, we also see that we hit the holes that we anticipate. So this is a beauty of the BIM design and 3D design. We feel we have very good control over things that would be very hard to do in 2D. And then if we have a look at again here's the joint that we had a look at.
What is the joint made of?
Steel and rubber, because this the thing is the abutment that's built into the into soil, so that doesn't move at all, but the bridge itself expands with heat. So
and contracts,
yeah.
It's a fugue, right? What is the word in English?
Joint in English, fugue in Norwegian.
Yeah. Okay.
And we can then have a look at, for example, if we have a look at the reinforcement, we can then see quite easily what needs to be done. Does it clash with anything we've made so far, and what needs to be adjusted for this to fit, and what bars need to be added so that the joint is properly connected. So having when you write these contracts on third-party products, we see an importance for the people manufacturing and building to have good contracts where it states that the third-party deliverer needs to deliver their product in 3D BIM models. That's getting more and more important. Because if you only had these 2D drawings like these ones, you would very easily get a surprise at site. Of course, it's been done for hundreds of years, and they've managed, but the quality control that you're able to do now is unprecedented.
Yeah, that's not an argument. Like that would be a reason not to improve at all. So if we have a better solution, like we definitely must employ it. Like it will lead to more security for people who are working. Not forget about this, the very important aspect: saving money, and building it quicker, maybe, right?
Yeah.
So yeah.
No, I agree. And then we'll have a look at smaller projects like we talked about in the opening. Now this is a small. Well, it's relatively small. It's about 4 or 5 meters high. It's corner foundation, one of 4 in a structure in a building, and it's concrete, and there's some quite enormous forces going into this structure, but it's relatively small in width, and from a 2D drawing, we see that there's enormous amount of reinforcement needed in here. And when you're doing the design for the reinforcement, it's very, very hard to see in 2D drawings if this is going to fit or not. So if we were then asked if we could do a 3D model of the reinforcement, and we'll have a look at the model here now. Let's see. That's something else. So here.
Oh, what is this, a stadium?
I wish I could tell you. I can't tell you.
It's okay. It's fine. No problem.
But if we see here now, it's packed with reinforcement. It's it's really, really hard to make it all fit. It's we worked a number of hours to make this fit, and of course we see some eventual some small clashes, but we knew that we're going to be able to do that.
It's going to be very difficult to pour the concrete here.
Yeah, but I'll show you pictures because it's already been casted.
Oh yeah, okay.
So let's see. Yeah, so this is how difficult it is to fit.
Oh yeah, Jesus Christ.
But
like you need to use a syringe to try to
yeah, but without the 3D modeling, it would be a lot harder because here you have in some of the sections you have 5 layers that want to compete for the same space.
Yeah. Well, if you don't have like how I think here, like if you don't have the 3D model, there might be a possibility that you cannot build it, because you did here when you did it in 3D, you see that you have place. If you encounter a challenge, you try to fix it before you did that, right? Imagine being there and being forced to fit all this, and you cannot do it. Just stop the entire crew working and try to find a solution, right? How much expensive is that to do?
Definitely. And as you see, this is a test casting, but it looks beautiful. And again, if we see some of the layers here, for example, this one, how we have to how we skew them to make it all fit.
But regarding the one clashing, like what is the thing with them?
The ones that we saw clashing down here.
Yeah.
Well, these ones, when you model them, you can start bending them separately.
Yeah.
But as often as possible, you want a rebar to be part of a group. You don't want to explode it, so every rebar is unique.
Yeah.
So if you can see from your design that clashes are solvable, then allowing small clashes like this it's okay, because you can see that if I tilt this a little bit, we will have space.
So what is the measure? What do you do then to be sure that it won't be a clash on the site? So how do you fix this?
On this side, I could show you quickly. Let's see.
But before, in the first place, if you would not have a 3D model, you would not have seen this.
Definitely not. And I'm sure they eventually would fit it all, but it would take a lot of manual labor, because what we're able to do now is we can do automatic rebar takeoff with bar bending schedules, so that a machine can bend all these rebars automatically.
Yeah.
And then we do sequence like this, so that people at site know which ones, which of the bars goes first.
Yeah. Oh, okay. So you from up down, you just have it in the order how they should place them.
Yeah, at least our suggestion on how they should place them.
Yeah, sure, I understand. But nice, very nice.
Yeah.
Well done.
Thanks. And then on an information takeoff, we can automatically take out bar bending schedules, and say if I only wanted to take out rebars for the lower part, then I'd just mark these ones, and then do a bar bending schedule for those. And then maybe tomorrow I could do another one of the top one. So it gives you quite a lot of flexibility on large projects, especially when you want to order things.
And do you make any notes in the bar bending schedule for the series of bars that you could not fit in the 3D model, or how do you exactly you handle this?
We could do that, yeah. So if we have a look at this one, when we have a number of attributes that we've attached to every object, and here we have a number of open comment fields that we could add attributes or information if needed.
Okay.
In this case, we've only had we haven't added much information because there was no need to. But on the Ranselva project, we have a lot of information there. So so the casting was I was very impressed by the shape of these. So
yeah, it looks like art.
Yeah, it does, doesn't it?
Yeah.
Let's see, what else should we mention? Yep. Just an interesting comparison between the this is the hammerhead of Ranselva at axis 2.
Yeah.
And then we see what it looks like at site. So it's fun when things matches, and we clearly see here how they've used the information at site to build exactly what we plan. And it's been mentioned before, but we are of course very proud of that we won the Trimble Global BIM Awards for Best Project in the World 2020. And the last time someone won, it was this project. It was the Museum of the Future in Dubai. So that says something
really
about
nice company. A really nice company to be a part of.
Yeah, it was, and it says something about how far infrastructure projects in Norway has come, and how important it is that you have a governing party. Like from our case, it's Statens vegvesen and Nye Veier and Vegdirektoratet who work with the industry to standardize data and sort of lead the way to and saying that we accept BIM models, we accept third-party control of models and not drawings. So that's we've been lucky that in that way.
Yeah, that's very important. And let's not forget about Bani Noor. Bani Noor is also doing a great job.
Yeah, definitely. Yeah. And to let's see, before we go to and speak about site vision, I just wanted to show something as well, and that's standardization of reinforcement data, because when you don't have drawings, let's see if I can find a slide on this. Yeah, I don't have a slide there, but when you do drawing of, for example, a section, then what you're making is a principle that can be applied to 50 cross sections.
Yes.
And controlling it is fairly easy. But when you do model, then you actually have to control all of the reinforcement of the whole model. So if this was a bridge, then instead of just controlling a section, I would have to control all of this reinforcement. And by seeing all of this reinforcement, it's hard to see if there's one rebar missing. So what you want to do is somehow classify your rebars so that it's visually easy to control. So if you, for example, see this one, bottom bottom slab longitudinal reinforcement, or the
yeah, it's easy to understand. It's easy to see if is something missing or something misplaced.
Correct. Yeah. No, I totally agree. So and same with, for example, the wall reinforcement. Here we see that it's there's nothing missing, but to do that you need to classify your rebars very well. So we've used quite a lot of time on these what we call mock-ups, which are simplified, maybe 1 meter wide parts of the bridge, where we try to sort of make our rule sets for how what our model will look like. And whatever you're going to do with your BIM model, making these mock-ups will be one of the smartest thing you do. And especially like for things that you want to use parametric design to make, it's very important. And also for challenging parts like blister areas where you have tendons coming. Let's see if we can have a look at that here, if I find the right. Let's see, that was the short version. Can you see my screen now?
Yes, yes.
So here we have a fly through of the bridge, and we can now see the tendons here, and where the tendons stop. You have different tendons stopping in different casting segments, and where those segments or tendons stop, you have what you call a blister that we see here. And that blister takes there's a lot of compression force there. So in the old days, the reinforcement of this area it's very complex. It's very heavily reinforced, and to see that your design actually would work, you would do a mock-up, a full scale on-site mock-up.
Wow.
And these mock-ups we now do in our computers instead. So if we have a look at it there. But the challenging part here is modeling. We have about 500 connecting points, so we have about 500. Let's see, or that's a bit much. Say maybe 300-400 blisters, and every one of these blisters have unique reinforcement. And every reinforcement blister have about 100 different unique rebars. So if you do the math, it's a lot of manual work if you can't make rule sets that define them.
Yeah. Yes, it did.
So understanding your principles and trying to make these mock-ups, then it gets very important. So that's yeah, a trick to anyone, like a tip to anyone that's going to do this themselves. Then using a lot of time making good mock-ups for everyone to understand what they're up against. It's good.
Yeah. Sounds like a very sound advice. Thank you.
Yeah. Then we'll go on to speak a little bit about Trimble Sight Vision. And Trimble Sight Vision, for anyone who's not seen it, let's see, we can have a look at this video. Oh, here we see, well, first of all, we'll have a look at the device itself. So this is Trimble Sight Vision. It's antenna connected to some kind of display, and the display has this program called Trimble Connect and Trimble Sight Vision, where you then able to display holograms on the phone. It's a bit like Pokemon Go, just the
augmented reality.
Yeah, basically that's what it is. And if you use this is SketchUp files, and by using SketchUp files, you're able to do a lot of graphic stuff. And you can also import IFC files. The good thing about IFC files is then all your metadata can be reused. And to get this placed correctly, then you need the antenna where it places it down to it's quite accurate. It's accurate enough to do most tasks. 2 centimeters there is a normal accuracy that you can get down to. For example, here on what we're seeing here, we were going to build this retaining wall, but at the back of the retaining wall, there's let's see if I can see that. At the back of the retaining wall, there's a huge landfill. So if the retaining wall was too close to this landfill, then we would have to remove like 15 meters height worth of rocks. It would take forever. But by quickly adding it to Trimble Sight Vision, we could then easily see that this can be built in front of the wall. So that was not a problem at all. So it definitely has its place and value. The hard thing about this product, though, is that whenever you have something shadowing your satellite, then it gets hard to place it correctly. But you can use it without your antenna as well. Like we'll see here, this is just me goofing around at home. So this is just a pretend rebar mock-up to protect my own popcorn.
Yeah.
So and yeah, so my boy wasn't at least virtually able to access the popcorn.
Yeah.
And the good thing here is that you could press the rebars.
Yeah.
And then you could
read the information.
Yes, correct. So that potentially this gets very valuable when you're at site and wondering what rebar number is this I'm about to install.
Exactly.
And then you could say you were to check another sofa in your home, because this is done only on a phone. At this point I don't have the antenna connected. And then if I want to do design, for example,
like what do you mean that you did it on your phone? Like, can you install Sight Vision on your phone?
Yes, correct. The only thing you can use it normally, and the gyro in your phone understands when you use the phone where the model is supposed to go. Of course, you have to place the models manually, so they're not geo-referenced. And of course, accuracy is not it's not millimeter accuracy, but for my kids to understand what we're going to build in the back of the house, that was enough.
Where did you design this in SketchUp?
This is a Tekla.
In Tekla, you did this woodwork in Tekla?
Yeah, and then I imported it into SketchUp and added some colors, if
Okay.
I remember correctly.
Yeah.
So yeah.
Nice.
Yeah, it's silly and it's just goofing around, but it also shows
It proves the worth of this technology. Yeah.
definitely, yeah. And then when you bring this to site, we have some other things here. This is about 1.5 years ago, I believe, when before they started casting the foundations at site.
Mm-hmm.
And this was also just to check what we were able to do with the Trimble Site Vision, just to get a feeling for what we were able to do before we promised too much and before we got dependent on it.
Mm-hmm.
You see here, it's quite a nice tool. The trick, though, of course, is to experiment enough with it so you know what it can do and what it cannot do.
Mm-hmm. Well, are there any things that you think can be better that are limiting the experience? Some important.
The speed of loading a model, like it loads your model quite fast, but when you're going to set it out, the antenna takes some time to connect the satellites to get the position right.
Yeah, but that is not something directly that has something to do with site vision.
Mm,
If it's
no,
with GPS, with the positioning.
yeah, I don't know enough about the technology to know where the bottleneck is, but and the other thing is filtering, because you have potentially enormous amount of data. You know you have maybe 200,000 rebars and you only want to see 5 of them.
Mm-hmm.
So, and you only have a small device to sort of with 4 buttons to press. So how do you make filters that work, and how can you push small models taken from a huge model to your device without too much work? So
Yeah.
that's
So
all.
yeah. What about the preparing the IFC file? Like,
Mm.
do you it involves a lot of work to prepare it to make it usable for site vision, or it's quite straightforward and it goes fast?
It's quite straightforward, but the problem is that when we do our deliveries to people at site, we push the whole bridge.
Yeah.
You know, we don't want to. Well, we divide the bridge into maybe 20 IFC models, but for IFC to be useful, they need maybe 1,000 smaller models. So, and we don't want them to be dependent on us to prepare those 1,000 smaller models.
Mm-hmm.
So those models should ideally be pushed from an IFC model, maybe.
Mm-hmm.
And
Mm-hmm.
so how do you choose only 5 objects out of 200,000 objects?
Yeah.
It's probably quite easy to do, but I haven't seen it yet myself.
Mm-hmm. Yeah. Well, it's the technology is still at the start, right? The potential is there and is definitely going to improve over the next few years.
Definitely.
But the potential and the usability, I have no doubt, it's is definitely enhancing and helping with building and verifying, checking things as well. So I have no doubt it's going to be, before we get replaced by robots on building site, definitely is going to be a technology that is going to be very present on many building sites.
Yeah. No, I definitely agree. And it's it's coming in ever increasing speed. It's more for the challenge for us is keeping track of what's out there and what is useful and what's useful and cool and what's only cool.
Yeah.
And it's getting harder and harder to keep track. And but then again, it's I guess you have to see it as possibilities and not and not yeah.
Yeah, and you know what is interesting? That actually the next week, let me quickly check to be sure. No, it's in 2 weeks, I guess. Because we are talking about AR. I will have a guest presenting actually a competitor of Side Vision called VGIS in 2 weeks.
Yeah. Oh, nice.
So yeah, I really see a lot of potential in this, and I want to learn more about it, and yeah, spread the word.
Yeah, cool. I'll attend your live show.
You are more than welcome.
That was what I was gonna show you. I guess if anyone has questions, then we could do that now.
Yeah. Okay. I had some questions. I asked some questions during time. I had more questions, but I forgot about it. Let's see. I'll try to remember while I read the people watching, I guess, questions. Let's see. So, Heiko Denis, AR usually reacts to images, barcodes, and similar. I understand that the antenna is used to get the GPS coordinate and compare it to the ones given by the model file. How did your phone recognize the cupboard without an image or antenna?
When you use Trimble Sight Vision, you choose you exported your model into global coordinates, so that the antenna then understands, or the device understands, where to position your model. So in Norway, we're using what's called NTM. I think it's like Norwegian something. Yeah, I'm not sure what the abbreviation is for, but at least it positions it where it's supposed to go, and that's not something that you have to tag at all. So you have some one or several files. It could be a combination of IFC files or DVG or whatever, SKP, yeah, SketchUp files, and then it combines those at the correct place.
Okay, cool. Next question. Terje Fjellby says that Side Vision uses the GIS antenna, a laser, and the camera, so you can only use compatible devices since it calculates the distance from camera lens to laser antenna.
Yeah, I think you could set that up if you it has some mobile devices that it prefers, but I think if you measure the distance between your camera and the equilibrium point of your phone where you connect it, you could basically use any phone, but it also needs to know the field view, like the camera setting of your phone to know what level of zoom it uses, for example. So I think at least we have a Samsung device of some sort that was yeah, that was what they suggested we use.
Isn't it working on tablets?
Yeah, I think you could use that too.
Because that would be bigger. You'll get a bigger surface to work with, right?
Correct. Yeah, that would be beneficial. But of course, if you're going to hold it and walk around with it, it gets quite heavy. Your hands get tired if you're going to stretch them out and hold this device for a while.
Okay, cool. Let's go to the next question. Michael Victoriano, what are your criteria for breaking up your models into multiple individual models?
Yeah, no, good question. What we see is that we normally have a reinforcement model and a concrete and cast in model, and tendons, that's one separate model. and axis is one model, and information tags is one model, and then backfilling is one model. So, and then also, for example, if we have a look at this bridge in this view, every axis and every pier in every axis is one separate little set of models. So because when you're going to control it or build it, you very, very seldomly need all information at once. You probably only need this one smaller part. So, but I could open a model just so we could see it.
Sure. Awesome.
See. It'll take a little bit of time to load it, but while we wait, we could talk about it. And why we divide it is that you normally don't need very much information at once. You normally only here we have axis 4 of the bridge, and if we have a look at what kind of IFC models this is, so we have reinforcement here. We have form. We have a form of the superstructure just to understand what we're going to connect to. And then we have information tags.
Annotations, yeah.
Yeah. And then axis. And when we combine these, then they turn into this one. And the filters that we use, let's see. So every element that we model here has the same kind of attributes connected to them, whether that is information tag or concrete or reinforcement. They all have the same tags, and that means that we could start using these kind of filters. They go across the different IFC files and can be used for all elements.
Yeah.
So again, the whole model is probably made up by 40 or 50 IFC files.
Awesome. I hope that answered the question, but it was very detailed. Thank you. Let's see. When do you see these type of technologies going to be used more widely, and what are the obstacles in front of them spreading more and more? I think it's referring to AR, augmented reality.
One thing is it needs to be faster to load and more user friendly, because today you need specialists to sort of handle the device. It's a bit too complex and it's a bit too expensive, and it's also whenever you're in a shadow of something above you, it's sort of the position of your model, so it is lost. Yeah. So for example, if you're looking at pipes in the ground, it's very useful because you don't have anything above you. But if you have scaffolding around, then often you'll see that it loses position, and then it takes a couple of minutes to get it back, the model back, and that's no one has time for that at site. So that's the obstacles I see myself, at least.
Yeah.
But georeferencing things that you can trust is in the right position, that's very, very valuable and useful. So if we see it compared to Microsoft HoloLens, for example, which is a helmet that basically does the same thing, but the models are referenced by, you need something, it's not based with GPS signals. that's also useful, but then you need some kind of markers in the area where you know where they are. And the problem with HoloLens is too that the technology is you need quite a lot of education and understanding of the product to sort of place things fast.
Early days, yeah, early days.
Yeah.
Like I completely agree on that. It's still early days of the technology, and definitely that is a barrier. But let me say something. I think most of the serious companies in Norway are dipping their toes into this. They are using it, even if it's challenging. I believe most of the biggest ones are using in most of their projects, or they are trying it.
Yeah, no, definitely.
Many projects, right? So if you are a company and you want to see the potential, you definitely should try, because you cannot understand this just waiting and watching, looking for other people how they use it. You need to try it on some project. These tools provide some demos, and you can find interesting things. And of course, they are limiting, but still, even with limited functionality, you can unlock potential. You can unlock things that you cannot do, you cannot imagine. You need to or you can do only in your imagination. So
yeah, no, and there's not very many standardized ways of doing it yet, because it's so new. So you, as you mentioned, you need someone that has enough time to play around with it. It's like anything that you're going to invent or do for the first time. You know, when they invented antibiotics, or if whatever you're inventing, you don't know what you're going to invent. You have to play around with it, and then suddenly you invented something.
Yeah, exactly. No, but not only for construction industry, AR is here to stay. It's a huge, it's a many billion dollars business that is just growing and growing, flourishing and booming. And especially for us, because on the field it's so practical work involved. So it's definitely, the tools are not there, the technology is here, and the interest is there. So there are not only in Norway, because I know about VGIS and definitely Site Vision as well. They have companies in many other countries that are trying it. So it's just a matter of time until it will become mainstream. But it's also a choice, right? And who won't use it won't become very effective. Like, people using this will become more effective on their projects. It's so easy. Like, you will end up saving time and money.
Yeah, it's definitely a complementary tool that helps you solve other things. But you also need some what some colleagues of mine are referring to as fuck you money, that you eventually think you're going to throw away to experiment with. But with some luck, you'll or most probably it's going to come something useful out of it.
Research and development definitely should be something for, you should have at least one guy. If you have I don't know, if you are a decent sized company, you should have somebody to try these things, because it's so much happening, right? And there are many things that you won't find the right way how to use it, and you won't understand everything how it works. But one simple thing can lead to huge improvements on your projects, and which will lead in to profits in the end, right?
Definitely, yeah.
Okay, let's go ahead. Terje is asking, parameterization of the rebars in the undergirder for the cantilever bridge. Do you get dropping lengths?
Can you repeat the question? You said undergirder of the
undergirder for the cantilever bridge. Do you get dropping lengths?
Dropping lengths. Oh yeah, lengths, I see what you mean. Yeah. Yes, we have parts of it. Let's see if we could. I could start another model that takes a little time. But yeah, we have dropping lengths, and there again we've used comments on. Let's see. Yeah, we'll it will take a little time to load, but yeah, as if I understand the question correctly, in the bottom here, even though we have reinforcement going longitudinal here, at the bottom you'll have rebars that has to be cut if every rebar should be the same length.
Mm-hmm.
And also, since this height is longer than this height,
Mm-hmm.
we also have dropping length vertically.
Mm-hmm.
But we've solved that by we've said that we need a minimum splicing length, and then further in we have length that are where the splicing is theoretically too large.
Mm-hmm.
And let's see if we have the model here. So here's 1/3 of the superstructure. Takes a little bit of time to load. And again, we see that we have a number of IIC files that make up the whole thing. We have reinforcement, and we have form, and we have information tags, and we here also have tendons like this. And if we have a look at here we can do, for example, pouring stages. And if we have a look at this one, we can see that we have a splicing length here. And here they are a minimum of the splicing length. And when we come to this point, then they'll be a bit too long.
Mm-hmm.
But that's a cost of standardizing the rebars instead of having all of them unique.
Mm-hmm. Yeah, but I think you must make a choice. Will you save more time or more resources? Or yeah, you must find a balance there, right?
Yeah, definitely. Yeah. Do we have any more questions or?
Let's see. Victor, great presentation. Thank you, Øystein and Petru, for sharing with us. Thank you,
Thanks.
Victor. That's nice to hear. Terry again, how do you convey the relative tendon placement in the cantilever part for the workers?
Yeah, that's there's several ways of doing that. Again, when we started this project, we had an idea of how it was going to be done, and now if we could do it again, we would probably model objects going from, let's see if I add this one, and we will probably model objects going from this point down to some kind of surface, so that you would have another IFC file here with data, for example, from the bottom of your tendon down to the underside of the concrete. And there you could read metadata from that object quite easily.
Mm-hmm.
We're getting into the detailed parts of the modeling now, but I guess if I didn't answer the question good enough, then just contact me on LinkedIn or wherever, and I'll see what I can answer.
Yeah, cool. So do that, Terry. Let's see. Michael Victoriano, thank you for answering my question. I learned something new today. Thank you, BIMvoice, Petru, and Øystein. You're welcome, Michael. Victor is asking, hello, didn't get the presentation from the beginning. Are you still preparing 2D drawings? Sometimes we don't model everything. How about the other details?
Yeah, I on this project, in some cases we have third-party products. For example, let's see, again, these ones, drainage, where as initially when PNC is building this bridge, when they contact their people producing the drain, then they sometimes prepare 2D drawings. And also we have 2D drawings as principles for backfilling underneath the reinforcement, for example, beneath the foundations, because the problem with excavation ditch is that it never looks the same from day to day. So it's a lot better with a principle here than a 2D or a BIM model that's always going to be outdated. So we probably have about 10 drawings on this project with principle things.
Yeah, well, regarding the backfilling, you don't really need to be that accurate either. It's not like reinforcement, right? So it makes sense to but yeah, maybe in the future, I don't know, will be another solution, or I have no idea. But yeah, that sounds good. 10 drawings instead of how many would you guess would have been necessary for this project?
Between 200 and 300.
Okay.
And what we're making are the least time-consuming ones. So the really time-consuming ones, they would take a lot of time. So, but again, kudos to the people at site. They are the heroes of this experiment. They are the ones. People at PNC has been fantastic in first taking our models and then using the models in new, very genius ways. And then people at site who's never worked with BIM models before, they've always worked with drawings, and then they managed to make this huge and vastly complex bridge, and being one of the first teams in the world to do this. And
that's impressive.
I'm very, very impressed by the work they do. So again, now they are the heroes in this.
Yeah, and because if they would not agreed to do this, then you have no reason to do it, right, in the first place. So it's about the entire team.
Yeah.
And the client as well. The client as well willing to approve this, right? Because maybe you have a client that doesn't want to hear all this noise. What are you doing? Don't try anything crazy on my project. Do it the old way or something, right? So I think it was a great team to have it.
Yeah, and also, of course, if they couldn't do it, if you want to but you can't because it's too complex and it's written with errors, then we would understand that we were doing something wrong and had to maybe go back to 2D drawings. And and for my part, I've tried to think about this like I don't want to force this method because I like it, because it has to work both in third-party control and at site. And if it didn't, then I would be happy to go back to 2D drawings. But then I'm happy to see that
it's working. But sorry, by the way, how much of the bridge is built?
About 35% now.
Okay, so there is no doubt that it's possible to finish it this way.
Yeah, no, I'm certain.
Okay.
Everyone has their doubt at some point, but yeah, no, I'm positive that this will be okay.
Very nice to hear that. Amazing. Great work. Okay. Terry, thank you for your answers, Øystein. Yeah. I don't have any other questions.
Thanks again for inviting me.
It was amazing. Thank you very much.
As always.
And thank you very much for everyone that asked questions.